In this lecture, we're going to talk about how to find the area of a general triangle. We have a general triangle. This is the same picture that we used when we generated the law of sines. So we have our same lettering system on this triangle here. So when we talk about the height of a triangle, we're really talking about the altitude of the triangle, and you have three possibilities. So if this is your base that you're choosing to work with, then this is your height, and they're going to be perpendicular. If this is the base you choose, then your height would be perpendicular to it, emanating from its opposite angle over here, and this would be your height. And if this was the base you chose to use, then your height perpendicular to that base going out to this opposite angle would be here. So that would be your h that you'd have to calculate there. So you have three choices for the base and the height associated with that base. Any one of those three combinations would give you the same area. So the area is calculated by the formula area equals 1/2 the base times the height. So you have three options. The base and the height, of course, are always going to be perpendicular to one another. Depending on the information that you're given in the problem, you will most likely need to calculate a side or an angle. All right, and we will use the law of cosines or the law of sines as necessary. And we've learned how to do that in the last two sections on the law of sines and the law of cosines. All right, and then we need to calculate the height or the altitude using right triangle trig. And this is the same thing that we did when we developed the law of sines. So briefly, what I'm talking about there is that if I wanted to calculate this height, and that would go with this base here perpendicular to it, so my area calculation would be 1/2 the length of side B times the length of that h, that altitude. And I could calculate that h using that bigger right triangle or the smaller right triangle, or I would say the sine of A is equal to h over the hypotenuse side, C. Or if I was using this smaller triangle, I would say the sine of the angle C is equal to h over the hypotenuse on this smaller triangle, which would be A. So I would say h is equal to c sine of A, or I could say h is equal to A sine of C, right? And that's where that would go right here. So in the end, I would be plugging in C sine of A or A sine of C. Okay, so that's what we're going to do, and we've got a few examples here. So here we've got our laws that we're going to employ, the law of sines in both of its forms, and the law of cosines. And here's our lettering system, which is consistent, and we would have to make sure we did our opposites, B, B, C opposite C, A opposite A. Example 1 says, find the area of the triangle, make a sketch, and I'm given side, side, and side. So I'm just going to make a general sketch. I'm going to put my letters on it, opposite, opposite, opposite. I'm going to put my dimensions on it, 16 for A, 35 for B, 31 for C. I'm going to write down my formula for area. Area is equal to 1/2 times your base times your height. All right, I'm going to arbitrarily say that I'm going to choose side B to be my base. So if side B is my base, I can see that I have 35 for that side. Then my height perpendicular to my base would be here. So in order to calculate that height, as we mentioned earlier when we were talking about the general triangle, I need either this angle or this angle in order to do right triangle trig to find h. So I'm going to arbitrarily choose to work with this angle over here. So I'm going to find this angle here. Looking at the information I'm given, if I'm going to calculate this angle C here, I cannot use the law of sines because I don't have an angle side ratio to set up here when I've got a side problem. So we're going to use the law of cosines. Law of cosines. All right, so if I'm going to find the angle C, I need the C law. So I wrote down my C law. Now I'm going to substitute in the numbers that I'm given into my C law. So I've got side C squared, side A squared, side B squared, minus 2AB cosine of the unknown angle C, which I'm going to solve for. So I'm going to start with 31 squared, subtract 16 squared, subtract 35 squared, and I plug that into my calculator and I get negative 520 on the left hand side. Then I'm going to multiply negative 2 times 16 times 35, which will be the coefficient of cosine C. I type that into my calculator and I get negative 1120 as my coefficient of the cosine of C. So now I divide both sides and I get the cosine of C, and I'm going to keep all of my digits. And I get that. Now I'm going to take the inverse cosine of both sides to find angle C. So I get the angle C is equal to 62.336 degrees. Let me just put my angle mark here. All right, so that's this angle here. Now I can calculate my h by using right triangle trig. So standing on the angle C, h is my opposite side. So sine of the angle C is equal to opposite over hypotenuse, where the hypotenuse of this right triangle here is 16. So I'm going to fill that in. I'm going to substitute C there. So let's go ahead and cross multiply and divide first. So I'm going to say h is equal to 16 times the sine of C. So h is equal to 16 times the sine of 62.336 degrees. So you're in mode degrees, of course. So you always got to be making sure when you're doing these calculations that your calculator is in degree mode. So I got my h now. So if I want to calculate my area, I can now substitute my h and my base into the area formula. So this is my area formula. So area is equal to 1/2 the base. In my problem, my base, I said, I'm going to use at 35. And then my height is that 14 number that I found down here at the bottom. So plugging all that in, I'm going to type that into my calculator to get my area. And I rounded to the hundredths place, and I got 247.99. So this is square units here. If you were given feet, it would be feet squared, whatever it is, inches squared, yards squared. Your units are squared when you're calculating an area. All right, so that's example 1. So let's just say that not everybody's going to choose the same base, so this set of calculations may vary from student to student, but if you get everything correct and you make sure you don't do any internal rounding in these problems, you should arrive at the same area. So you want to be very careful that you're not rounding internal to your problems on any of these calculations leading up to the end here. Once you get to your final area number, then you round to the specified number of digits depending on the instructions in your problem. Example 2 says, find the area of the triangle, make a sketch. So let's make a sketch first. So I'm going to draw my triangle, ABC, ABC. I'm going to put on my dimensions. 33 is angle A, side C is 14, side B is 28. Looking at this diagram I have here, I'm going to choose my base. So I can see that if I choose side B as my base, which would mean this would be my height perpendicular to my base from the opposite angle B, I'll already have this angle here to calculate my height using right triangle trig. So I'm going to choose this as my base here, and my height will be here. So here's my height perpendicular to my base. All right, so my area formula is area equals 1/2 base times height. So I already know my base, so I just need to calculate my height. So if I'm standing on the angle 33, this H is my opposite side, and side C would be my hypotenuse. So using right triangle trig, I would say the sine of the angle A is equal to H over 14, my hypotenuse. So then sine of 33 is equal to H over 14. So that means H is equal to 14 sine of 33. If I type that into my calculator, I get H is equal to 7 point, keeping all those digits. All right, so now I'm ready to go ahead and do my area calculation. So my area is going to equal 1/2 times my base, which is 28, times my height, which is that 7.6 number. So typing all that into the calculator, I'm going to get that my area is equal to 106.749 square units. So here's my area, rounded to the thousandths place. So the 3 pieces of information that you're given in the problem are going to determine how many calculations you have to do. This was a rather short problem, relatively speaking. In this problem here, I'm given a drawing already, a diagram. So I went ahead and I put my dimensions on the diagram. So let's just go over your choices for base and height. So if you choose this side as your base, then this is your opposite angle. So if you were to draw the height, you would have to extend your base out so that you could get the perpendicular drawn. And this would be your H here. So that's an example of your altitude being outside of the triangle. So that's one option. Then the second option would be if you chose this side A as your base. So that would mean angle A, opposite side A is out here. And once again, you would have to extend your base out far enough so that you could get your perpendicular drawn in here. And this would be your H here. So that altitude is outside your triangle as well. And your third option would be to choose this longer side here, side C as your base. And this would be your angle opposite, so your perpendicular would be internal to the triangle, like this. So this is the one I'm going to choose. I like to choose my perpendiculars inside my triangle. It's just a personal preference so that I can see my two side triangles pretty clearly here. It's more of a classic look to what you're used to seeing when you're like in, I guess, middle school, when you learn how to find the area of a triangle. So that's going to be my H. So here's my base here, 32, and I need to calculate this H so I can plug them into my area formula. So let's write down the area formula. So there's my area formula. Now let's come up with a strategy for finding height. So I can find my height using either one of these two right triangles and employing right triangle trig. If I choose this right triangle here, I have the angle opposite the height, but I'm missing this side here, which is my hypotenuse, so I'd have to calculate side B. If I choose this right triangle here, I have the hypotenuse side 23, but I'm missing the angle opposite the side H. So either one requires a calculation here for this side, here for this side. So I'm going to say, let's just choose this triangle here. So that means I need to calculate this angle here, angle B. So I can set up the law of sines because I have a side opposite an angle, and I can calculate this angle C opposite this side here. Once I have this angle C, I can subtract both angle A and angle C from 180, and I'll get angle B, and I'll be good to go. So I'm going to set up the law of sines. So that's the sine of 28 divided by its opposite side, 23. And then I've got the sine of the angle C opposite the side, 32. So that means sine of C is equal to cross multiply and divide. So I'll just show you one way to speed this calculation up a little bit if you're interested in this. If I take the inverse sine like it is now, you can type in inverse sine of an expression just like this. And you could save yourself a little bit of work that way. So that'll give me angle C, and I get 40.7816 degrees. Now here's why I have to be extremely careful, because I can see that I've got an obtuse angle right here. All right, this is a side-side angle configuration, side-side angle, which is the ambiguous case of the law of sines. So the reason I did use the law of sines here is because I had my triangle drawn for me already, and I could see that this is the obtuse case. As you can see, this is an acute angle. So from what we learned about the ambiguous case of the law of sines, I need to find the obtuse angle that gives me the same sine of C. So to do that, if you'll recall, I'm going to say the real angle C is equal to the supplement, which is 180 minus 40.7816. Because if you wanted to check to see what I'm talking about here, what I'm saying is the sine of 40.7816 is equal to the sine of 180 minus 40.7816. This is your Q2 angle, this is your Q1 angle. So we went into that in the law of sines instruction. All right, so my real angle C is obtuse, so angle C is equal to, if I subtract that, 139.2184 degrees. Okay, so that is my angle C. That's this angle right here. So let's just draw a little arrow here, right here. That's your angle C, your obtuse angle. So now I can figure out angle B because I know the other two angles now. So angle B is using the angle sum theorem, 180 minus 139.2184 minus 28 degrees. So angle B is 12.7816 degrees. Okay, so now I've got what I need. Angle B is 12.7816 degrees. So I can say the sine of angle B is h over 23, and I can calculate h. So let's just scoot this up a little bit. So the next calculation, sine of the angle B is equal to h over 23, that's my hypotenuse. So h is equal to 23 times the sine of B, 12.7816. All right, so that gives me an h of 5.08841. All right, so now I've got my height, I've got my base. I can substitute into my area formula. Area is equal to 1/2 base times height. So my base, once again, is 32. My height is this 5.088 number. So substituting into that formula for area, I get my final answer here of 81.4146 square units, whatever your units are. And be careful that you round according to the specified number of digits in the problem. Okay, once again, I did no internal rounding. Before I got to my last and final line here, then you can do some rounding if you're asked to do so. All right. So our last example is to find the area of a given quadrilateral. So this is an irregular quadrilateral. All of its side dimensions are given here, and I wrote them on the diagram. And then the angle here, angle A, is given as 103. So this is the given information here, and I'm going to find the area of this quadrilateral. The way I'm going to do that is I'm going to break it up into two triangles right here. Just drawing that line, BD. And so I'm going to find the area of this triangle. And my tools to do that are law of cosines, law of sines, and right triangle trig. And then for this triangle over here, I'm going to find the area using law of cosines or law of sines and right triangle trig. So I'm sticking with the basics. Of course, there are other ways to do problems, but I'm going with the basics for calculating triangle areas using our three things that I just mentioned, and I'm going to add these two areas together to give me the area of the entire thing. All right, so let's start with this triangle here on the left. I'm just going to say this is the base I'm going to choose, such that this here would be my height. So let's draw that in. So my base, and I'm going to call that side E right here. I haven't used E yet, so I'm just going to use E. This is a right angle. And then this right here is my H. So the next thing I'm going to do is I'm going to calculate that length E. What I can see here is that I've got an SAS problem, which is a law of cosines problem, where I can find this side length opposite this angle 103. So I would say the sine, not the sine, I could say side E squared, so E squared is equal to A squared plus, that's this side here, A squared plus B squared. So my letters are not the ones I'm used to using here because I have more letters in a quadrilateral, but we can still do it. A squared plus B squared minus 2 times A and B together, times the cosine of the angle opposite the side E, which would be that A, big A, the one I'm given. All right, so that's the setup for the law of cosines. All right, and once again, this side is opposite this angle. These two sides are the ones on either side of the angle I'm working with here. This side and this side on either side of this angle here. 103 is the included angle. All right, now I substitute in my known quantities. The only thing I don't know is this side here, E. I know everything else. So I substituted all my quantities in, and I plug that into the calculator, and I get E squared is equal to this quantity here, and then I take the square root of that number to get E. So now I have my side E. That's my base. So now I need to find my H. So in order to find my H, I need to do right triangle trig on either this triangle here or this triangle here. So let's just say I'm going to use this smaller triangle here. So I'm going to go ahead and calculate this angle here. Let's just call that angle D. So I'm going to find this angle here, angle D. All right, if I look at this triangle that I'm working with over here, I can see that at my obtuse angle here, 103, remember you can only have one obtuse angle, physically speaking, in any triangle, so that's already known. So I can say this is an acute and this is an acute. So I'm safe using the law of sines. I won't have to worry about any ambiguity there about whether or not it's a true solution to this triangle. So if I set up my law of sines to find this angle D here, I have a pair here. Sine of 103 over E, I can say is equal to the sine of the angle D over 5.2. That'll allow me to calculate D. So I'm going to set that up. So I've set up my law of sines to find this angle, which I'm calling D right here. So cross multiply, divide by this number. You should get the sine of D equal to this number here. Then if I take the inverse sine of both sides, I will get angle D. So now I have angle D. So the next thing I want to do is find side H. So if I'm standing on the angle D, this is my opposite side here. So I'm going to say the sine of the angle D is equal to opposite side, which is H, over the hypotenuse side, which would be this side here, 3.9. So I can say H is equal to 3.9, the sine of D, which is this 44 point, all that. All right, and if I type that into my calculator, I will get H is equal to this number here for H. So I can say the area for that triangle I'm working on, the left triangle, I'm going to call it area 1, is 1/2 my base, which is my E number. So my E is all the way back here, this 7.1675669 times my height. And this will give me the area for the first triangle. Okay, so I've got that area. I'm just going to keep those 5 digits to the right of the decimal point. All right, so I'm halfway done. Now I got to figure out the area of the larger triangle on the right there. Okay, so let's go ahead and figure out that area next. Let's do that over here. So let's go ahead, since we've got this base already calculated, let's use this as the base again, which means if I go perpendicular from its opposite angle, that would be my height. All right, so we got a different set of values in this triangle on the right here. I don't have any angles given to me here in this triangle here, but I have a side, and a side. So I can do the law of cosines to find one of the angles in this triangle right here. So let's think about this a minute. if this is my base, I'm good with that number, and I've got both of these sides, so I could choose this right triangle or this right triangle to calculate my h. I have those hypotenuse numbers there, so I could really either calculate this angle or this angle right here. So let's just say we'll calculate this angle right here. All right, so let's go ahead and find this angle right here by setting up the law of sines with this side, side, side triangle here. So I would say, remember we're dealing with lettering system that doesn't match up with our way that our laws are written. So if I want to find this angle here, that's going to be my angle way on the end, on the right end, and this side opposite is going to be what I'm going to start with, 9.2 squared on the left side. So then I go ahead and I need the sides on either side of the included angle, so that would be 7.3 squared. And then E is the other side, on the other side of that included angle here. So I need that side next. So that number was, that's E squared. Now I need minus 2, I'm running out of room here, 2 times 7.3 times that number times the cosine of the angle B. So the next thing I'm going to do is I'm going to take 9.2 squared, subtract 7.3 squared, subtract this E squared, and I'm going to get a number on the left-hand side. So that's the number on my left-hand side. Now I've got on my right-hand side, negative 2 times this times that times the cosine of B. All right, then I'm going to divide the left-hand number by that coefficient of B, and I'll get the cosine of B. And then I'll take the inverse cosine of both sides, and that'll give me my angle B. So I've got my angle B is this amount of degrees, and that's this angle here. So remember, what I'm trying to do is now find this h dimension. So I could say the sine of the angle B is equal to h, that's opposite, over 7.3, that's hypotenuse. So that's 7.3. Now I'm going to solve for h. So h is going to be 7.3 sine of the angle B, which is that angle. Typing that into my calculator, I'll get h is equal to this number here, 7.16511. All right, so now I can find the area of the second triangle. So the area, let's just call that area sub 2, is equal to 1/2. We've got the same base, this same base here, but we're using this h here. So I type that into the calculator and I get my area. So I typed it in and I got this second area is equal to this 25 number with these digits to the right. All right, so now I can add those two areas together. So let's just get them in the same window here. I can add area 1. Here's area 1 for this triangle, area 2 for this triangle, and that'll give me the area of the quadrilateral. So our total area is area 1 plus area 2. So I add both of those numbers together, and I get my final answer here. The area of the quadrilateral is equal to the sum of the two areas of those side triangles. So here's my final area here. If you were given units, they would be square units. All right, so these kind of problems, finding area of a quadrilateral, are a good way to practice all of your basics, because you're finding the area of two triangles using all of our tools in the toolkit, law of sines, law of cosines, right triangle trig, and then you're adding both of those areas together to get your final area here. All right, so the strategy that we used was to use this internal diagonal here as the base for the left triangle and the right triangle, to use side angle side law of cosines to find the piece that we needed for this piece over here to find h, and then over here we had side side side, so we used law of cosines again to find the angle that we needed to solve for h. So then we just added those two areas up. All right, so it's a lot of work, but it's good practice for learning how to find the area of a general triangle. All right, so this concludes the examples we're going to do for section 4.3 on finding the area of a general triangle using law of sines, law of cosines, and right triangle trig.